minutes early because this is a really long talk, and I apologize for that. I work for these guys. Just like pretty much everyone else in the world, we're hiring. So if anyone wants to come work for Booking, we do really cool stuff with big numbers, experiments, and building for scale. So if anyone wants to do that, come chat to me afterwards. We do, however, work in Perl. All right. Security theater. The practice of investing time and effort into creating the illusion of security rather than actually doing anything about it. Now, some of you might be aware of this. There's some very great world examples about security theater. If anyone knows what these are, you have a great story to tell the person next to you afterwards, because I really don't even have time to go through all of this. But we're not going to be talking about this today. We're going to talk about what we, as developers, are doing and why it is security theater. Because a lot of the stuff we do around security doesn't work. And this is a hard fact to swallow. In fact, so hard, we're going to have a little bit of a breakup with our illusion. And the first stage of any breakup is denial. And you're probably going, I'm a good developer. I watch what I write. I'm not going to have a problem. I'm not just talking about what we do as developers. I'm talking about everything we do, the whole process, from our own development machines to our servers, to our customers, the whole thing. You might say, I know OWASP. Any of you do not know what OWASP is? The Open Web Application Security Project. They're the guys who put out a list every year saying these are the top 10 reasons why everything is shit. And have some very good guides on how to fix it. And that's great. You're probably not going to be compromised because of your code, but you're still going to have a problem. In fact, getting compromised by the OWASP plus top 10 is no longer a sophisticated attack. It's just the basics. And when I talk about compromised, I don't mean just hacked. I mean losing things like your reputation, data loss, financial loss. And anyone who doesn't think reputation is important, anyone know about a company called DigiNotar? There you go. Saying you're secure because your code is secure is a sign of security theater. But you use antivirus. Let me introduce you to a system called crypting. Crypting is not so new, but what it is a service where you write some malware, then you use all the market-available antiviruses to scan it, and to see which one of them say, it's a virus or it's not. Then you run it through an obfuscation program, and then you run it against all those antiviruses again. And you keep doing that until all of them go, this file is fine. This defeats pretty much every single form of heuristic antivirus out there on the market at the moment. And it's worse. They're organized. They have websites. They offer REST APIs that you can integrate with your Jenkins build process to take your binary, upload it, obfuscate it, send it back to you in a nice little package. They support you on Twitter. They take Bitcoin. They're organized. You can find them on Google. This is the first hit on Google just for searching for crypting. On the flip side, let's look at the people who are protecting us. So, besides the fact that Node recently released a vulnerability that was right in the core that allowed arbitrary memory reading, MicroTrend decided what they really wanted to do was put one on your computer. And that allowed anyone whose website you visit to run anything they want on your computer, or lift all your saved passwords from the Trend Microsystems password manager. And it's not just Trend. Sophos, I think that's a UK company. Remote mail execution. They didn't bother to check for buffer overflows in the thing that scans for viruses. So every single time they scanned for a virus, the virus could take over your computer. Any disk operation your computer does, the antivirus scans it first. So I could take your computer over by sending you an email. So Sophos would scan the email, compromised. But unless you're feeling left out or feeling, confident about your own company that you use, I've compiled a comprehensive list of every piece of antivirus software that hasn't had a major vulnerability in the last 2 years. Now, I could keep going on embarrassing the industry more, but we have a limited amount of time. Internet of Things. God. This is a problem on its own. Who has one of those at home? When was the last time you updated it? Thank you. If anyone has ever had to connect to their router, they know it runs a web server because you load it in a web page, which means it has Apache or Nginx or something like that installed, and probably has Linux as a kernel. It also means it has OpenSSL, because that's what you need for Apache. But most of those were bundled about 5 years ago, and haven't changed, which means pretty much everyone's router here is vulnerable to Heartbleed, if anyone ever heard of that. Pretty much your router, the gateway to your home, is a big invitation to anyone to walk in. And this is what everyone has now. The internet of shit is going to expand to everything else in your house, which probably has the same kind of update cycle as your router. In fact, Shone is a Google for finding all those things. If you want to find an unsecured web server in America, type it in. They'll give you a list. And then there's people like Samsung. Anyone ever bought a Samsung phone? You know, the first thing that happens when you get it, it asks you to update. And then you never see that update notification again. Because Samsung doesn't bother updating their phones 6 months after it's been sold. Who has a phone for less than 6 months? Most of us are on like a 2-year cycle. There's a Dutch advocacy group trying to get Samsung to agree just to keep updating your phone for those 2 years from purchase. Because it's not like the phone has everything to do with our life on it. Fact is, we're all pretty bad at security. Are users bad at security? I mean, the recent list of the most commonly used passwords for 2015 came out. Number 1, still, surprisingly, 1, 2, 3, 4, 5. Although of interest, number 6 is now Star Wars. Developers are pretty bad at security. I ran this search about 3 weeks ago. Thanks, guys. Still submitting your secure authentication keys to GitHub. Even the hackers are really bad. The author of one of the encode viruses, which once it gets on your computer, will encrypt all your files and demand a ransom, otherwise you'll never get your files back again. Apparently, the encryption doesn't work properly. So I'm going to take a quick step out of our breakup with our illusion and talk about a project I've been working on since mid-2012. It was with a small hosting company in South Africa, and they were having problems with their hosting environments, mainly shared hosting environments, which are pretty much the worst. They were having problems where their customers were constantly being compromised. Their websites were being hacked, and they were spending a lot of time having to fix and get their servers up and running again, especially if it's one of the shared ones where one website will affect all the others, because shared hosting is the cheapest, worst possible setup to actually run a website on. And so we sat down with them, and we built up a list of the most commonly used software that they were aware of on their hosting environment. And we built up a list of 43 applications and built a fingerprinting system. In total, we've imported about 4,800 versions of those applications. In total, over 10 million files we've indexed to be able to identify what versions of software are running somewhere. And then we started scanning every month. We ran the scan on every website to see what versions were there. What software were they running, what version was it, and then we'd cross-index those with what vulnerabilities were known. In total, we processed 255,000 scans, about 6,000 per month from June. And these are the results for July 2015. Now, I would show more recent data, but they had some server changes, and pretty much the results from then onwards are a lot less statistically significant. We've got a lot fewer, because they shut down some of the servers, didn't set it up on other servers, and I'm here. But this is probably the best, most recent results I have. So, let's start with the fun stuff first. What do you think was the most popular piece of software All right, right. Before we start, and we'll do this like the British, hands up. I have a wisdom of the elephant that I'll give away to either the person who guesses it or the person with the most funny answer. All right. This was the distribution. All right. Any guesses? Nope. Nope. OS Commerce? No. PHP? MyAdmin? No. Joomla? No. No, we already had Joomla. Not Drupal. Sorry? MIDI? Oh, MediaWiki. No, not MediaWiki. Who said TinyMCE? I didn't even have to get through to the hints. That's Joomla. That's WordPress. There's Drupal. TinyMCE. WordPress uses TinyMCE. PrestaShop uses TinyMCE. PHP BB uses TinyMCE. Sugar CRM, I think, uses TinyMCE. Which is important because it means that if a vulnerability comes out for TinyMCE, it could potentially affect all these other things. So, fun stuff aside, how bad do you think it was? We scanned for July 6,440 websites. Of those websites, we found 1,082 that had something we could identify. All the others either were placeholder websites or static websites or were custom written or used a piece of software we didn't actually bother to index or, commercial off-the-shelf stuff. On those 1,082 websites, we found 2,324 different software installs or libraries and so forth. So any guesses on how many websites with all the software on it were vulnerable? You guys are way more pessimistic than me. All vulnerabilities normally range on a scale from 1 to 10. 1 being information disclosure, stuff that won't necessarily compromise your machine, but will provide some information that could be leveraged to do something else. Like you might tell someone what your version of PHP is, which won't mean the software is compromised, but we can then go and look up PHP vulnerabilities and use those. And then 10 being SQL injection or remote file inclusion or remote code execution. Pretty much, they now own your machine. This is good. This is good. We've got some people who aren't vulnerable, but more people who are, in complete trouble. I mean, and then there's a little bit in the middle who are not quite sure which side they're on. Pretty much, almost 60% of all websites were vulnerable to at least one vulnerability. Some of them absolutely terrible. It could be worse. Now we know who's actually to blame here. So let's just exclude all the others and just look at the CMSs. So, interesting to note, WordPress has an auto-update system, which means a lot of them kind of sit over here. But also means these guys are just not trying. And of course, no surprise, Joomla. Drupal, I have no idea what it's doing over here. Less statistically significant, but interesting nonetheless. The frameworks. Really, we do not have the numbers to make any judgments here, but I'm judging Zend. So why is it so bad? It comes down to time. We brought in all these vulnerabilities and compared them to the versions in our system, and we could work out, based on when a version is released, how long it took for a vulnerability to be discovered for it. The median time it takes for a version to be released to us finding a problem with it, not that there was no problem before, but finding a problem, is just over 20 months. Although you can see these huge spikes right here. So we could actually say 25% of all software is vulnerable within 3 months of release. Which is fine, as long as the average age of the websites and the software they're running is less than that. Oops. So the average age of the websites is 26 months. Although, as you can see, there's a nice little spike here of all the people who updated fairly recently. Although, because websites you tend to get more websites over time, people want websites, then they add websites, and then they sit there forever because it's shared hosting, and you're only paying like, what, £2 a month? People tend to add websites all the time, so I kind of expected a hockey stick anyway, because people are adding websites faster than the older ones are getting older. These were quite interesting, these spikes here. Those were specials that the company ran, where people who previously were on the fence about paying £2 a month decided, oh, we'll get a website. And they installed a website, and then they forgot about it. Now, this looks bad. This is an improvement. Because when we started the project, one of the goals was to start informing the customers. So at the end of 2012, we started sending out notifications to everyone to say, hi, your website's vulnerable. Please update. So what it was before was about 30 months and a lot more distributed. So this is an improvement. We've reduced the number of vulnerable websites from almost all of them to most of them. There's a little side-by-side comparison. All my effort and all the efforts of the company and contacting the customers has moved the bar from there to there. Was it worth it? Because let me tell you, I have seen things. Horrible, horrible things. Like this. What the hell is that? I do not know if a vulnerability goes above that or below that. What's the next one in the line? This is not even the worst one. The worst one, anyone who works with WordPress or WordPress themes might have come across something called TimThumb. It's a little one-file application that allows you to do snapshots of your website, maintained by someone who has no idea how to version. The version is stored inside the file, which was fun. But also, he didn't update it every single time he updated the file. So a vulnerability would come out, he'd fix it, but then he wouldn't bump the version number. So we had to do some absolutely horrendous things. Also, not the worst thing I've ever seen. OpenX had a backdoor in it for over a year. OpenX, which was previously PHP add, new add, which became OpenX, from 2012, November, to August 2013, it had a big backdoor built into it that no one knew about. Shortly after 2013, it was bought by another company and changed to Revive ad server. So if you're running PHP add new or OpenX or Revive ad server, you might want to rethink it. But the worst thing I saw was this result. Now, this guy obviously got the idea that you want to update your software, but he didn't quite catch on that you're supposed to remove the old one. So we have, what is this, 1, 2, 3, 4, 5, 6, 7, 8 Joomla installs in backup, 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 old backup, 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 old stuff. Also, he's running Joomla 1.5. Joomla is now on 3.5 beta. This is 2015. Another interesting fact is there is so much copy-paste code in Joomla 1.5 that my software was having problems identifying the root of Joomla. It kept thinking the administration folder was another Joomla install. So what did I learn? I learned that projects with bad versioning are bad at security. That automatic patching, if it's available, gets used. If someone couldn't update because it would break a plugin or a template, and they had a choice between running a vulnerable website and no effort required, and updating it and spending time and effort, they wouldn't update. We need to make plugins and templates updatable. Joomla, I'm looking at you. And finally, patch fatigue exists. When we first started informing the customers about these vulnerabilities, I'd send them an email saying, "Oi, this website, you're running this, please update it to at least this version." And we'll get a reply back saying, "Thank you very much. That was incredibly useful. We've updated it." And we pat ourselves on the back. And then 2 months later, when a vulnerability comes out with that version, we send them another email. "Hi, another version, update, please." And they go, "Well, okay, fine. Update it." 2 months later, we send it again. "Hi, that version is now vulnerable, please update." And they're like, "Jog off." So let's get back to our breakup. Anger. Why doesn't someone do something about it? Well, the private industry, unfortunately, at the moment, still has a very lawyerish attitude towards security. A lot of security researchers still get threatened with lawsuits. I myself have been threatened by a lawsuit. Now, some tech companies have started offering bug bounties, which is great, but those are the exceptions. Generally, it's don't tell anyone, always send our lawyers. Because if no one knows about it, it is secure. I have had to integrate multiple payment gateway systems before, and one of them had a whole slew of vulnerabilities, which I reported on their incredibly terrible customer portal. It was closed the next morning. But, quite interestingly, I found the customer portal didn't encode anything. So I resubmitted the bug report with some JavaScript in line, which disabled the close button. That's when I got a letter from their lawyer. They didn't fix anything, and we still had to implement it because it was a decision handed down from above. And that is something we, as developers, need to change. I don't feel comfortable handing my customers' details over to these people, but I didn't have a choice in the matter because it was dictated to me. This is something we need to push back. Unfortunately, lawyers are very expensive. And quite honestly, they're not doing a particularly good job themselves. Well, you might say, why don't we have some form of standard for this? You know, some standard we could get behind, come together, work one out, then we say everyone has to follow the standard. You can get the insurance companies not to insure you unless you follow that standard. No problem. We do. We have a whole bunch of them, actually. And they're for different things as well. Some of them actually conflict. You can't do certain combinations of them because they will tell you to do different things. And let's say the top one, the ISO 27001/2 one. Apparently, it's a very good one. I don't know. I'm not going to spend 650 euros to pay to read it. I'm definitely not going to spend 50,000 euros to get certified in it. And that's actually completely useless for me if I want to do credit card systems, because I need the plastic card industry security standard, the PCI one, if I want to deal with credit cards, which is a completely different one, with a completely different approval process. And if I ever want to work with the American government in some form, I need this one, because they won't accept any of the other ones. All right, you say, why doesn't the government do something about it? Not so sure I trust these people doing that. And quite honestly, most of them haven't got their act together either. And they still haven't figured out it was the Russians. I don't have enough time or slides to put up every single incident in the last year from government side. So we'll use this as a catch-all. And quite honestly, even when they aren't getting compromised, they're not really helping us out much. Sort your act out, guys. And when they're not trying to compromise our security, they're just compromising our security. There is one small ray of light out of this, the government's side of security, around disclosure laws. where if a company gets hacked and they lose certain amounts of information, they need to disclose it to their customers. A lot of this is still very optional and only applies to certain types of data, but it means now that you at least get told you've been screwed over. Let's move on. Bargaining. Things are bad, but maybe we can make a plan. Maybe we can make a plan. I don't know. Let's install some IDS systems or web application firewalls, or get some specialized network equipment to handle our security. Yeah, we could go to one of the industry leaders like Juniper, who build security hardware. They actually only found out about one of the backdoors in their system because the NSA told them. I think the NSA told them because they were kind of fed up with having to share the routers with the Chinese. So one was definitely the Chinese's backdoor, and the other one we're pretty sure was the NSA's. And I don't know if any of you have ever had to maintain an IDS system before, but waking up at 1 in the morning because some manager in some remote office has managed to trigger the IDS system to lock them out because they have been visiting some really dodgy websites. I'm talking about Cold Fusion websites, yeah. Cold Fusion, by the way, sets all their cookies to global, which means once you visit a Cold Fusion website and you go to another one, you have all the Cold Fusion cookies sitting there. And it kind of looks like a SQL injection because they pack all this stuff in it. And quite honestly, I've had to water down IDS rules so much to make sure that people who should have access, that they're not going to warn me about major problems. You might say, well, we'll start following some of those prescribed security standards that they came up with. Pay the money, verify ourselves, get started. That's great for your insurance premiums. Because a lot of these standards are checklists. They are pretty much, you cannot work with us unless you've ticked every box, regardless of how weird or obtuse that tick box is. And, of course, they get used by your insurance companies to determine how much premiums you pay. But they're not really going to make you that much more secure. Remember, these are the people who still think an 8-character password with 1 uppercase, 1 digit, and no special characters is secure. I like to think of this whenever I feel depressed, because it means there's 10% worth fighting for. And now that we're past the depression phase, we can move on to acceptance. And accept this new reality and start thinking about what we can do to fix it. So, why are our practices not effective? Most of them are pretty ineffective, but not for the reasons you think. It's because we do security in isolation. Bolt it on, after the fact, quick patch, make it work, get up and running again. But security is not something that should be done in isolation. It's holistic. It's the whole thing. This is our area of influence, the software and the dependencies we have. But there's this whole other stack that we don't exert direct influence over. That is part of the security. I mean, if we actually distort these to show a number of lines of code for each section, it'll probably look something like that. Your tiny little bit of code up there. And I set that to 500,000 lines, which is about your average Joomla install. There's all this that you're depending on to be right. I mean, technically, the human DNA is about 7 billion lines of code, so if we include humans, it's actually more like that. So I'd be more worried about the security vulnerabilities in this code. So you need to reach out to these other parts of the system. You need to reach out to HR and training. Make sure they know how to reset passwords, how to reset accounts. You need to reach out to your sysadmins, and I hope you have some really good sysadmins, because they make all the difference, to deal with all of this. And the internet is full of eels, so you don't have much control over that. Security is led, should be led. When a part of your system gets compromised, they shouldn't suddenly have full access to your whole system. Preferably, there should be another wall with really pissed off archers on top. Security is about your attack surface. Where can you be attacked? That's where you need to marshal your forces. That's where you need to pay attention. Security is about alertness. No one here wants to be the company that says, well, apparently our system's been compromised for the last 6 months, but we just found out now, so that's good. You are more likely to be made aware that your system is compromised by being woken up at 2 in the morning by a really pissed off DBA saying, your code is making my databases too hot. Sort that shit out. And then you load it up and you'll find out, oh, someone's doing a SQL dump. Your IDS isn't going to do that. Pissed off DBA is. And trust me, pissed off DBAs are scary. You will check. Security is about mitigation. If someone gets into your system, they need to be limited to what that part of the system has access to. So if someone compromises your CMS, there's no reason at all they should have access to your customer information. If, and I understand that marketing might have a valid reason to have that WordPress site, but if they insist upon having a WordPress site, make sure it is so far away from the rest of your system that you have to communicate via smoke signal. And finally, security is about trust. Wait. I thought the whole point was trust doesn't work with security. But it is, actually. A lot of security is about trust. It's about being aware of what you're trusting. The hardest part of security is not writing secure code. It is understanding where you misplaced your trust. Because trust is a chain. I trust my computer here is not compromised because it's up to date. And also it's Linux. Not running any antivirus, of course, because you're more likely to become vulnerable. If you're running Windows, run antivirus, please. I trust that the software I'm using is without vulnerabilities. And we found out that via vulnerability research and security updates. I trust that the software I'm using is properly configured. If you have to provision 50 servers, I hope you're doing it automatically. Because if you make one mistake there, you could have accidentally left one of your servers open for all sorts of abuse. Most software, by default, comes with the most broadest permissions enabled, so you can get the service up and running. Because no one wants to figure out why the LDAP connection is not working with you. They set it up, gets working, then you start restricting it. That's how most software works. I trust that the network I'm using is configured properly and secure. Hire yourself good system administrators. I trust that you are who you say you are. You log into the website, you give me a username and password. I now assume it is you and not your brother who's stolen your password. When you connect to a website, I trust that they are who they say they are. And we do that via peer verification using certificates. And if anyone is aware how that works, every computer ships with a bunch of root certificates. And these are the companies that sell SSL certificates, mainly. And they say, if that certificate on the remote website is signed by one of us, it's good, you can trust it. I mean, that's why we pay exorbitant fees for these certificates, is for them to do due diligence and say, yes, you are who you say you are, because you can afford this money, actually. That's the only reason. And that we will keep our private keys secure. The company I spoke about earlier, Diginota, that no one seems to know about, was one of those companies, Dutch company. They lost their private key. Within a month, they were bankrupt because every single certificate they ever issued became invalid. By the way, anyone here aware that Windows can install new certificates, root certificates on your computer without even informing you? Not even through the update manager? Oh, Uzbekistan is now requiring everyone in the country to install the government's one for reasons. I trust that we're allowed to talk about what we're talking about. Hi, I'd like my bank balance. Not the same as authentication. Authentication is I am me. Authorization, I'm allowed to do. I trust that what you sent to me hasn't been tampered. I'm going to send you a file. You trust me. You'll just install it. exe, run it on your machine. How do I know that someone hasn't modified that file when I send it to you? We can use hashes or signatures. Did someone modify the email I sent to you? Has someone tampered with this binary? I trust that what we talk about is private. No one else can eavesdrop on our conversation. Public and private keys. We trust that the system we implement here works. I trust that your computer is not compromised. I have absolutely no way to verify that. I trust that what we talk about, you won't share with other people. There is no technical solution to this at all. Contracts, yes. Legalities, yes. Terms and use on the websites, terms of use and conditions and all that kind of stuff. Yes, sort of. But there's no technical solution to make sure that you won't turn around and tell the person next to you what I just told you. Hi, Facebook. I'm having a baby. That's great. We won't tell anyone. By the way, would you like to buy this push pram? I trust that the user won't be the weak link. Good training and procedures will help with that. But how can we make this chain better? We have this chain, and the weakest link in that chain breaks, and the whole system falls apart. If we can turn those interleaving links into more of a mesh, we can make ourselves more secure. We are spreading the trust around. And we can do it with things like two-factor authentication. Not only do you need to have a username and password, but you also need to have a specific token. Then if you lose your password, someone else gets it, they still can't use it because they need the token. If you are dealing with large amounts of money transfers or refunds, is one person allowed to put in the number and refund to anyone they want? Because that's a great way to go on a very expensive holiday. Do you have someone else who has to come along and sign off on those? There are now 2 people dependent on that. A lot harder for abuse to happen. Signatures on emails to make sure they haven't been modified. Encoding your HTML output when it comes out of the database because you don't know who put it in there. These are all extra checks you can add. And if you have to make an assumption, is there a way you can code for that assumption? Because then there's no need for it. And there are a lot of common mistakes we make that break this trust. Generally, breaking the trust involves weakening one of the links. Normally, it's around encryption or hashing. That's where we really get it wrong. How we implement it will affect its strength. For authentication, I can go on for hours for this section, but pretty much, there you go. Two-factor authentication. I actually could not create a slide that was simpler than the README on this. Uses Google app authentication, include it, voila, two-factor authentication. Although, even better, make someone else have to deal with your customer data. OAuth makes it someone else's problem, which means you don't need to deal with all the legal issues that come with holding someone's data, like the right to be forgotten, and what happens when you lose all that information. Sessions. Never roll your own. Here is a mistake that was made in PHP MyAdmin. And it's not a mistake most people would spot, because that bit of code now allows anyone to log in as admin user. This piece of code was used to allow someone to delete someone else's session. So this, by the way, if anyone has ever wondered why when you're running it on your test machine you have 2 pages open that take a long time to load, one won't start loading until the other one's completely finished, it's got to do with the session locks. This prematurely closes that session lock, because normally it ends at the end of the script, and writes it to disk. So write it to disk, open up a new session for the session ID we want to get rid of the session, exit. Great. Except for the fact for the little command right before it. Parse string. which takes a URL and imports it into the namespace, kind of like registered globals, because that was a good idea. Which also allows you to override the session variable, which means override the session variable, write it to storage, never mind the rest, refresh the page, you're now admin. Encryption. There's a very good reason for this. Leave it to the professionals. Even they get it wrong. Avoid all tutorials. If you take one piece of advice away from this, is ignore all tutorials in security, because generally security changes rapidly, and often the advice is bad. This URL here is to a GIST that's maintained by security researchers who keep it updated with the very latest industry recommendations for encryption, which formula to use, which random algorithms, HMACking. So if you are interested in that, avoid advice like this. Hi, I'm trying to use curl and I get the certificate verification issue. What should I do? Don't worry, turn off peer verification. Stack Overflow is riddled with these. I spend my weekends looking over Stack Overflow, finding these and adding very nasty notes to them. Thankfully, from PHP 5.6 onwards, a very nice guy called Daniel Lowry has made it no longer an issue. Pretty much, it finds out what your root certificates are, wherever they are on your system, and handles it for you. Unless, of course, you've done that. If you have, go through your code and remove it now. Hashing. Hashing is, once again, one-way encoding. Taking something and turning it into a new form that is smaller, easy to move around, and cannot be turned back. Very good for password hashing. And file integrity checks. Have I Been Pawned is a website managed by a guy called Troy something. And it lists all the publicly available dumps of passwords that have been released to the wild. They're currently sitting at 278 million accounts. Be aware that the number of internet users in the world, I think, is only sitting at 2 billion, so 10%-ish. So I think there's the Adobe hack in there, all the passwords listed. In hashed, encrypted, multi-hashed, plain text form. Pretty much 66% of those were either plain text, plain MD5, or encrypted, which you don't do with passwords because it means you can decrypt them. Which means with the rainbow table, 66% of the passwords in the world can be decrypted, which is why we know what the top worst passwords are in the world. And it's also implementation. There's stuff we don't know that can trip us up. Which of these two implementations of hash checking is secure? They both return the same value, true or false, in all cases. This one? That one? Yeah? The first one is vulnerable to something called timing attack, which I never knew about. It's brute forcing those functions by working out how long it takes to execute. Because with string comparison, as opposed to a slightly different formula which is used here, you can work out how long, if you try it enough times, it takes to compare two strings. So here we have ABCD and ABCE. We compare those 10,000 times, there is a distinct time. If we compare ABCD to ACDE, which only has to check the first two characters before it fails, you can see there is a distinct time difference. So you can iterate numerous times over and over again to see if you can get those string comparisons to match by working out the time. This can also be used to figure out if a username exists, because the first thing you do is pass the username, pass the password, checks the username. The username exists, let's check the password. Otherwise, return straight away. So you can use a username you know with a password you know isn't correct, and then a username you don't know if it exists, and just keep going through different usernames and compare the two times. And see if one of them, the time starts matching closely, then you know that username exists. Okay, I'm going to actually myself. Well, actually, those two hashing functions were actually fine for bcrypt, because bcrypt actually has enough randomness to make sure that they're not determinable. Sometimes. See, bcrypt is a bit of a balancing act. You either have a cryptographic function that is expensive to run and thus takes a long time, which makes it a DOS vector, so someone can DOS your website by hitting your login page, or you make it too easy and it's predictable. PHP 4.3 to 5.2.9 did not have enough randomness in bcrypt, which means all the passwords that were encrypted for any of those PHP versions were cryptographically not so secure and vulnerable to timing attack. But it's okay. We all store what version of PHP we were using when we created that hash, right? And the thing is, standards will change. Bcrypt at some point will be decided that it's not so secure. MD5 used to be secure, now it's not. SHA-1 used to be secure, now it's not. At some point, bcrypt won't be. And it's going to change. You notice we have a password default in PHP. That is the considered best default. So if you build your code like this, you verify the password, because the only time you should ever know what a person's password is when they're entering it into your website. At the time they enter it, you can check if it needs to be rehashed, because maybe a better formula's come out and you need to move up. You can do that with that check, and then just rehash the password and store it again. You'll never ever have to worry about using a weak hashing algorithm anymore. And then there's randomness, and you might be noticing a trend. Non-deterministic randomness is critical for encryption. Not only is it critical, it's hard. The dual elliptic curve something, something, something was used for 7 years. It was the default in RSA's software. Until people found out that it was actually planted there by the NSA and had a hidden mathematical weakness. It took 7 years to provide the proof of that. They were suspicious before. And I'm sure RSA were not too happy about the fact that it was disclosed they'd been paid $10 million by the NSA to do that. So 7 years to figure out that something had been planted there and was actually not secure by mathematical cryptographers. Don't think you can do it yourself. Also be aware where you're getting your randomness from. You don't always need cryptographic randomness. There's different types of randomness. There's pseudo-random, which is great for like non-important randomness. There's cryptographically secure random, which is important for cryptography. And there's true randomness, which is very expensive and takes a long time to process, and is useful for gambling games. Know where you're getting it from. RAND is not cryptographically secure, but RANint, random bytes, and OpenSSL random pseudo bytes is, until there's another vulnerability in SSL. Information disclosure. Every single time you ask for a website, they send a whole bunch of header information. This is some of the header information they can send. You might be particularly interested in those two pieces. Oh look, you're running Apache and PHP 5.5.11. That's kind of old. That's great. I can look this up. I know there's about 5 pretty serious vulnerabilities with 5.5.11. And now I know how to attack your website, because you've given all that information. Turn it off. No one needs to know that you're running PHP or Apache. Just change it to return IIS or something. It'll make Microsoft happier. There's a good reason we also turn off warnings, besides the fact Google will index this for you very nicely. It also discloses your paths. How many folders down do we need to get back down to your root of your system? It's not necessarily a vulnerability, but it allows you to leverage that information to use another vulnerability with the information you leveraged. And then my favorite, social engineering. Weak password reset processes. If I can Google the answer to your reset questions, that's not secure. Where did I live when I was 15? It can be Googled. What school did I go to? Googleable. Pretty much most of the questions they ask nowadays are very easy to find out. Make sure that your support staff is trained. there's this big toss-up between convenience and security. If you make it too hard for someone to be able to reset for a valid reason, they're going to bugger off elsewhere. But if you make it too easy, it's going to be abused. And I actually have an interesting story about that. This guy, whose name I'm not going to try and pronounce, has the Twitter handle N, and a hacker wanted that. So obviously, he's not going to hand it over. After a bit of looking up online, he found out that this chap had a domain where all his email went to, hosted with GoDaddy. And so the hacker went over to GoDaddy and he said, "Hey, GoDaddy, I need to reset my account. I lost my password." And GoDaddy said, "Well, I'm afraid we can't help you with that unless you can give us the last 4 digits of your credit card number." The hacker said, "Okay, tell you what. Tell me what the last 4 digits of the social security account is, because I'm not sure if it's mine or my wife's, and then I have to go and find which credit card to use." And they're like, "Sure. Last 4 digits of your social security number are XYZ. Thank you. I'll be right back." "Hey, PayPal, which credit card do I have attached to my account? Could you give me the last 4 digits? I think it's expired now." And the guy said, "Well, we can only give you that information if you provide us with the last 4 digits of your social security number." "Oh, well, there you go. Great. Here's the last 4 digits of your credit card number." Cheers. "Hey, GoDaddy, thanks for holding. Last 4 digits. Not a problem. Reset the account." Logs in, changes the MX domain, waits an hour, goes to Twitter, resets the password. Done. How do you defend against that? Whose fault was that? It wasn't Twitter's fault, I think. Was it GoDaddy's? PayPal? If you are interested in hearing more of this kind of stuff and the coding stuff, I recommend you pop on over to James's talk in the new Relic track. So, we've dealt with our breakup. Now it's time for a little bit of hope. Security is holistic. This is a problem that everyone needs to be part of the solution for. This is not something we can do individually. We need to remember our ABC. This is probably the most important advice I want you to take away from this talk. Always be patching. Have a patching strategy. If a dependency right now is preventing you from updating or patching, fix it now. It's not going to get any better. And what's worse is when something major does come out and you're stuck, unable to patch, you're going to be screwed. This also includes if you're using any kind of version of software that's kind of 0 point something, that hasn't released a stable release yet. Be aware of that. I think it was a Node, broke all backwards compatibility, and there's still people using 0 point something Node. Version properly. It makes my life easier. It makes determining what versions are vulnerable easier. Get it right. It's not complicated. Major number, it goes up when you break backwards compatibility. Minor, when you add a feature but it doesn't break backwards compatibility, you put that number up. And if it's just a fix to fix a bug or security issue, put that up. I should be able to update any change in the patch without ever having to test my code. It should just work. Don't become comfortable. If you're aware of a hole in your system somewhere, deal with it. The longer you leave it there, the more comfortable you'll become with it, the more contempt you'll show it. It's not that serious. Are your passwords still in MD5? Sort that out now. Not when we're busy uploading them to Have I Been Pawned. Read. Read. Know about what's happening. If you use any piece of software, third party, sign up for their security emails. Read up on the best practices for security from reputable sources, not Stack Overflow. 90% of security is about knowing what's going on, not about fixing stuff. Have a training strategy. Make sure your agents know how to reset locks on accounts, how to reset passwords, what process you go through. Make sure that they don't, it falls within a gap where you're happy with the level of security that someone has to go through to verify their own account, but not so far that they have to send DNA samples. Have a compromise strategy. Have a plan before you need it. Write it down. Store it somewhere. Practice it once a year. Even if your plan is we have no plan because we don't have time or budget, write that down. Because when shit goes wrong, you need to be able to find that plan. It should contain who needs to be contacted, what needs to be done, who needs to be informed, what systems need to be shut down. Talking about that, information. Only store what you actually need. I mean, marketing department might cry that they don't get like the third cousin's name of your customer, but store only what really is needed. The less information you store, the less you can lose. You're going to make mistakes. Learn from them. When you get compromised, if it's just a matter of patch it and carry on as normal, you haven't learned anything. Your company hasn't learned anything. You might find they're a little interested in the problem for a little while, throw tons of resources at it for about a week, and then they forget about it. If you suddenly get access to a lot more resources for security, make sure it's sustainable. Rate limits. Build it now. You don't want to build it when there's an incident going on. If you can only log in 5 times to your website, no one can do timing, attempt to log in 5 times a minute on your website. No one can do a timing attack. No one can do a brute force. This also applies if you have any kind of product that someone who wants to compromise your system wants to use, like AWS. Make sure everything is rate limited. Monitor. You're more likely to be notified by that DBA than the IDS. As was famously said by someone at Etsy, if it moves, graph it. If it doesn't move, graph it just in case it starts moving. Decouple roles. Put the data where it needs to be, far from each other. There's no reason why that WordPress site I was talking about needs to have any access to your customer information, and should be very, very far away from the rest of your servers. Compose everything. Makes it easier to update. There is no excuses anymore. We should be doing this. Decouple your plugins and templates. If I cannot update my plugins and templates, update my software because it'll break all of those, you're doing it wrong. We have Composer. Allow people to install plugins and templates via Composer now. And a personal request. Please get behind PSR 9 and 10. PSR 9 is about disclosure, how to get hold of you when we spot something wrong in your software, how you will respond, who you will notify. Once again, having that plan. And 10 is about how to store in a standard way vulnerabilities in your software. So people like me can easily import those lists. Imagine if you went to Packagist and you went, right, I want to install this version. And it goes, well, no, actually, that version has a vulnerability. Please don't install that version. That would be cool. We're not going to have that without that. This theater is group performance. This is not something we're going to be able to do alone. This is something we have to do as an entire group. Each of us is a link in our own trust chain, and we are as strong as the weakest link here. Thank you very much. Any questions?
You suggested turning off headers for things like software versions, patching, things like that.
Mm-hmm.
How much would you say you should think twice before talking publicly about what software you use for production systems?
No one needs to know what version of anything you're running on your website. Pretty much the header information is more for debug use than anything else. Yes, you might mess a bit with Webcraft stats when they're trying to figure out how many people are running Apache as opposed to IS and other things, but there's no reason to weaken your security for statistics.
No, I don't mean for statistics. I mean if you're doing a public talk or blog post or something like that.
Oh, none of that is got to do with anything that I'm running.
No, I'm not asking about you. What you're talking about some people do.
Information disclosure is quite interesting because it's something that people don't think is important until it is important, because it's been used to figure out something else. Limits as much as possible. Bare essentials, pretty much. Anyone else? Nope. Right. Class dismissed.